So we see that typically f or g of x and g or f of x, they are totally different functions. However, it could be the case that g of f of x and f of g of x turns out to be just the same identity function. In that case, this is typically a pretty special occasion. It's called the two functions, they are called the inverse functions of each other. Let me just let's just see by this example. My f of x is 3x plus 5 and my g of x is x minus 5 over 3. So let me just compute f of g of x. So that's going to be f of g of x. And, well, let's see. It's going to be 3 of x minus 5 over 3 whole thing plus 5. So you get x. And my g of f of x, it's going to be g of f of x. So it's going to be 3x plus 5, the whole thing minus 5, and divided by 3. And once again, when you simplify this out, you get the x. So in both cases, you will actually end up getting the identity function. So that means these two functions f and g, they are the inverse of each other. The next one, my f is x squared minus x, and my g is x minus x squared. Let me just go ahead and do that already. I think you guys are familiar with this already. F of g of x would be x squared minus x minus x squared minus x squared. Now g of f of x is gonna be let me see, it's gonna be my g, wait a minute, did I do it right? Nope, I didn't. Okay, so I make a mistake. What I had earlier, this is actually g of f of x, because I'm plugging f into g here. So my bad. My f of g of x should have actually been x minus x squared minus x minus x squared. Okay, that's a little confusing. But you can see that once you simplify this out, this thing is not gonna equal to x. And this thing is also not gonna equal to x. So these two guys, they are not inverse functions. So they are actually the additive inverse of each other. This one is x squared minus x, this one is x minus x squared. But in terms of composition sense, they are not the inverse function. Now then, sometimes you can actually work out what is the inverse function of a function by algebraic method. Typically, when you write a function, you will write y as a function of x. Now, if you can somehow manipulate that equation and write x in terms of y, then this guy is going to be your inverse function. So let me show you this example here. I have my f of x on my y is 5 minus 3 over 2x plus 2. So I have y in terms of x. So my goal here is that I want to write x equal to something in terms of y. So I would like to separate my x in the denominator here to be by itself on my left hand side. So let me manipulate this guy. Let's see, from here I can move this one to the other side. So I have 3 over 2x plus 4. So this should be a 4. It's going to be 5 minus y And then I compute the inverse on both sides, so it's going to be 2x plus 4. I move 3 to the other side, so instead of divided by 3, that's going to be 3 divided by 5 minus y. Now I can move 4 to the other side, so I'm going to get 2x equal 3 minus 5 over y minus 4. And finally, to just get the x, I'm just going to divide by 2 on both sides. So this is what I end up having. So I can simplify this a little bit, but let me just write the final answer. So the inverse function for this guy, or let me call it g, my g of x. Let me actually just call it f to the negative 1. So that's the typical notation for the inverse function. It's going to be, let me distribute the 2. So the inverse function here is going to be, when I distribute the 2, I'm going to get 3 divided by 2. So that's going to be 1.5 over 5. Wait, is it 5? Yeah, 5 minus y over 2. And that's going to be my final answer here. Now, there's a few properties that a function needs to satisfy for it to have an inverse function. The first one is that if a function can have an inverse, it needs to be one-to-one. So a function has an inverse function if and only if it's one-to-one. So one-to-one basically means that if f of y equal to f of x, then y has to equal to x. So if you have the graph of the function, then seeing if it's one-to-one function is pretty easy. You can use what is called the horizontal line test. So a function if an inverse, even only if you were to draw the vertical horizontal line, any horizontal line, it should intersect the graph at most once. So if you draw a vertical line intersect the graph here, so that's still good. However, if I draw this vertical line, you can see that it intersects the graph 3 times. So this guy, that means this graph is not one-to-one. And that's because I can draw this line that intersects the graph more than once. That means this function would not have an inverse. On the other hand, if the graph kind of have just one, if any vertical line has only at most one intersection anywhere, then that means the function here would have been one-to-one, and then that means this function has an inverse. Now, the graph of a function and its inverse are going to be the reflection. It's going to be the mirror image of one another about the line y equal to x. Let me just make a quick example here. It's easy to see that the function x squared and square root of x, these are the inverse of each other. So it makes sense in the common sense. When you square something and you take square root of it gets you back to the same number. If you take square root of something and square it, then it gets you back to the same number. the graph for x squared and square root of x that we see earlier, it's gonna look like this. So this is the graph for x squared. Let me actually just add the domain x equal to 0. So it would make the whole thing would make sense. Okay. So you can kind of see these two graphs, they are the mirror image of each other around the line y equal to x. Another quick example would be e to the x and log of x. So again, if you take exponential, if you raise something e to the something and you take log, you get the same number back. If you take log of something and you raise e to that number, then you get that number back. The graph for e to the x look like this, and the graph for log of x kind of look like this. So you can kind of see once again, they are the mirror image of each other about the line of y equal to x. So that's what we have here. Okay, so that's just one last example that I wanted to show you. So I like to determine if the graph has an inverse function, and if they do, sketch the graph of the inverse function. Now, the first one, you can kind of see that if I draw this vertical line, it intersects the graph more than once. So that means it failed the vertical line test, so this graph has no inverse. For part B, if you were to draw the vertical line anywhere, it would intersect this graph at most once. So this graph has an inverse, and the graph of the inverse is going to be the mirror image of this guy. Okay, it's going to be a little tricky to draw. Let me kind of try that. So it's going to look the first piece. The mirror image of the first piece looks something like this. The mirror image of the straight line. Right. Yeah. Okay. The mirror image of the straight line is gonna look like this. Okay. So if you flip the blue graph along the x equal to y equation, so if you find the mirror image of the blue graph on the red line, you'll get the green graph, which is the graph of the inverse function here.